good morning, afternoon, wherever you are. Super excited to be here today. Going to try and cover a decent amount of ground here. AI agent design, grounding, and evaluation. It was funny trying to put this together because this space is moving so quickly that I feel like month to month, even week to week, the amount of new content and developments out there, it's hard to keep pace with. So this will be very much, I think, a snapshot in time of where we are today across these subjects. Just by way of quick introduction, yeah, I'm a product manager in Google Cloud on the Vertex search team, and have been diving into the AI agent world and how we connect them to data, build them, evaluate them, all of that. So with that as a way of diving in, as mentioned, this is like the agentic era. What an incredible moment to be active in this space. And this is really about enabling AI systems and interacting with them that are able to start performing really much more complex tasks with really limited or even no human intervention, depending on the use case. So it's exciting. It's also interesting to think about this as, in some ways, like the next frontier of software. So this isn't just AI that's assisting you, it's AI that's like truly acting. So performing, again, complex tasks, demonstrating autonomous action. So this is a big thing. AI that's able to independently execute tasks and workflows, leverage reasoning and planning. So using these advanced AI models, making informed decisions, adapting to changing environments, a lot more like a human expert in some ways. These systems, these agents engage in continuous learning. So they learn from experience, refine their strategies, and improve performance over time. And finally, and this is something we'll touch on a few times, is multi-agent collaboration is now emerging. So this is becoming much more collaborative, much more like a team of experts, as it were, working together to achieve reasonably complex goals. And with this, there's a few different trends that we see emerging at this moment. And again, this is an incredibly fast-moving pace. One is multimodality. And so naturally, we're starting to break free in some ways from the limitations of text. So we can interact with these AI agents using images, video, audio, and I think this makes the experiences much richer and opens up a lot of interesting use cases. Agentic workflows is another one. So AI is becoming more autonomous, more capable, and we're seeing the rise of these AI agents that can reason, plan, as needed, adapt, which is really opening up a way to transform how we work and collaborate. And then the third kind of change is how the knowledge frontier is changing. And so it's in many ways redefining how we access and interact with information, enabling us to hopefully break down some silos and give us the insights we need to explore and iterate like never before. I'll give you a quick sample of how this is playing out across the Google world. You may have heard some of these projects. I'll just highlight them briefly. One is Project Astra, which is all about the vision of a universal AI assistant. So this is all about improving the quality of the dialogue, making it much more natural, adding additional tools to make the assistant more useful, better memory to remember things that you've interacted with it before. I think it's now up to about 10 minutes of in-session memory, and then continuing to improve latency just to make this experience much more native and natural. Another way that this is surfacing for us is Project Mariner. And so this is a prototype that's exploring the future of human and agent interaction within the browser. And so it's able to understand what the browser's there, what the pixels are rendering, understand text, code, images, forms, and start helping you there. And then obviously a super popular space in this domain, AI coding assistants at Google. This is Jules, intended to be our AI-powered code agent, enabling you to work asynchronously and still integrate with your GitHub workflows, enabling you to do things like fix bugs and other kind of time-consuming tasks while you do hopefully higher value work. So that's just kind of a quick overview of some of the ways in which Google is trying to materialize this opportunity. The reality is obviously this is happening across, I think, every single industry and vertical out there, and it's already happening. I think that's part of the fun and exciting thing about these moments. This transformation across organizations is active. You take retail and consumer, for example, creating entirely new digital experiences, kind of reimagining customer support. in healthcare and life sciences. And I think the impact is already starting to be profound. Seeing agents help diagnose diseases and pretty dramatically accelerate the pace of drug discovery. Even in relatively very highly regulated industries like financial services, you're starting to see agents emerge that are kind of fundamentally changing how firms are able to handle things like risk assessment and optimize some of their internal operations. And then naturally across tech sector, this is seeing widespread adoption. But the same pattern I think is true, media, telecom, manufacturing, whether it's in supply chain management or personalizing content. I think all of these leading companies are looking at ways to use agents to drive efficiency and create value. In a lot of ways, it's kind of like the new competitive advantage, the new backbone of that. So how do we actually get to this state? How are we enabling? How are we seeing developers take advantage of this? For our world, it's very much a platform approach to be able to design, deploy, and evaluate these agents across the life cycle. Just breaking down, what does an agent actually look like at this point? I think this is a reasonable representation of what AI agents look like at this point. It's a technique to give LLMs access to tools like your APIs, your data, and even other agents. And we can configure it with natural language instructions and examples. Give the agents access to different types of memory, like session history, user profiles, task profiles. And with that, you start having the form of an AI agent. And you can do it. You can ask it to do something with you in real time, or have it crunch away on whatever task in the background, and work through a dozen cycles, as it were, before it responds to you. And I think a lot of the Gen AI apps that we're interacting with already at this point are using an agent in one way or another, using tools and these kind of reasoning loops that are there. It's also been a fun evolution, as it were, of AI agents, and man, is it moving quickly. So looking back a little bit, you would start with an LLM with just a very basic prompt. Then you start seeing adding in retrieval augmented generation to start retrieving relevant context, relevant facts from data sources, whether that's your enterprise data or web search, and put those into the prompt. And then you start seeing the emergence of tools, function calling, enabling an agent to go figure out what API to call, what the right arguments are, and to execute them. And then finally, you start adding in a reasoning loop to see if we actually understood the user's intent, come up with a plan and review it, look at the tool choice that the agent's made, and doing all of that before sending the response to the user. And then this final state is basically this multi-agent framework, and really getting specialized for tools or specific domains or processes. It's not easy though, and I think this is where you start seeing what's coloring a lot of the investments that Google and our peers in this space are starting to make. I think one is obviously there's a skill gap today in terms of actually building out production grade agents. And some organizations, it looks like are kind of a tight spot. On one side, they're kind of focused on out of the box solutions. These can look really appealing, but don't always give you the flexibility that some developers and organizations are looking for. On the other end of the spectrum, there's the do-it-yourself approach. So you get tremendous control, but much more of the potential risk there. So you're responsible for all the security, the privacy infrastructure, navigating compliance, and chasing quality to manage the unpredictability that's a key part of these systems. And in the middle there, I think this is where we start thinking about agent ops and ramping up the skill set there. And then at the end of the day, it ends up being kind of a confluence of having the right people with the right skills in place, the right processes to go build out and deploy these agents, and ultimately the right technology as well. And we'll explore these in a bit. The other part is, all right, you've built your agent. What does it actually look like to bring this to production? And so this is ensuring consistency and reliability of the agent in production, optimizing the operational process and costs and expenses of running these, securely and effectively integrating them with other data silos and APIs, and as I mentioned a couple times, trying to keep up with the rapid pace of change, and that's an incredible task in and of itself. All right, so what does this actually look like from a platform perspective? And again, this is kind of like a very somewhat detailed view of how we think about the platform vision, but I'll try and break it down for you. On the right, you'll see that like a lot of the magic kind of starts with the models there. And for us, obviously at the core, it's Gemini. So these are models specifically optimized for complex reasoning, native tool use, and this layer really provides the intelligence alongside multimodal capabilities and access potentially for developers to hundreds of other models through our model garden. So being enabling developers to really work with and choose the model that's right for them. For developers, I think the heart of this system is that agent builder piece in the center. And so for us, and this is what we'll be exploring in a bit more detail, it's the Agent Development Kit, or ADK, for defining and orchestrating your agents. It's the Agent Engine, which ends up being the fully managed runtime to deploy and manage them in production. It includes a lot of the difficult kind of ops work, as it were, so monitoring, security, evaluation, and managing both short and long-term memory. And then on the left side, in Agent, the reality is it's only as good as its data, as the data it has access to. And so this is really about enterprise data and tools. And this is how you ground your agents. And so we think about helping to provide the connectors, the infrastructure for RAG, the hooks into the open ecosystem to connect your agents to the specific enterprise context that it needs. And with this as kind of like a developer platform, then you can start thinking about building this layer of AI applications on top of it. So I'll dive into a couple specific pieces that you saw in that kind of platform vision there. Starting out with ADK, and so this is our relatively new agent development kit, and the vision here is making it easy to build agents and multi-agent applications. And when you think about where ADK and some of the peers in the space fit in, we kind of think there's various levels of abstraction and trying to meet the user and developer where they are. So you can start at the bottom, the DIY layer, where you're building an agent from scratch using lower level APIs like LLM calls, function calling, using a storage service to store session data. And at this point, you're basically responsible for all the plumbing that's there. But the upside is this gives you a tremendous amount of flexibility when building agents. Now, moving up one level, the first level of abstraction here is potentially a low-level LLM framework. So think of LangChain, for example. You get some basic abstractions for the most common kind of language processing tasks, parsing, splitting, some prompt templates. There's still a fair amount that a developer ends up having to do in this space, and for some, there's a bit of a learning curve as well. All right, taking it one step up the abstraction level, now you're in kind of low-level orchestration frameworks. And so here there's greater abstractions around working with these models, enabling you to focus a bit more on the actual orchestration logic. So lane graph, I think, is an interesting example in this space. You can build graphs to design your agentic workflows. And again, that's one level of abstraction higher than LangChain. The next level here is that of an agent framework. And again, this is where ADK and some of its peers fit in. And yeah, if you look at recent kind of developments in this space, the interesting thing is it seems like the industry is relatively quickly converging on that kind of a similar set of abstractions for what building agents should look like. And so at the level of agents, this is things like tools, session management, and callbacks. And hopefully at this stage, it starts becoming much easier as well to start building multi-agent systems. Finally, there's the highest level of abstraction here, level 4 in this framework, and this is the no-code space. And I think there's also a handful of options here. And the idea is giving a lot of abstraction, obviously, and enabling users with no coding skills the ability to develop agents, albeit probably with the least amount of flexibility at this space. So with that, what does the ADK actually look like? And I think for us, it's all about trying to find that kind of sweet spot between ease of use and still maintaining high levels of control and quality. And so that's where we try and balance in that space. Some of the highlights of things that I think kind of drive the design intentions behind ADK. One is supporting multi-agents. So multi-agency by design. So you can build modular, and scalable applications using multiple agents in a hierarchy. A model ecosystem as well, so enabling you to choose kind of the model that works best for your needs, as mentioned before. Supporting that tool ecosystem that's out there, and we'll talk about this in a bit, but having pre-built tools, for example, like search and code execution, MCP, third-party libraries as well, like LangChain, LlamaIndex, or even other agents as tools, so LangGraph, Crew AI, whoever you prefer to work with, being able to leverage the best of that tool ecosystem. Built-in streaming capabilities, so being able to interact with your agents and kind of human-like conversations with bi-directional audio and video streaming support. Orchestration, a lot of flexibility there, and be able to define workflows if you've got predictable pipelines in place, or if it's a more dynamic use case, being able to leverage LLM-driven routing for that kind of adaptive behavior. And then, easy developer experiences. So a powerful CLI and then a web UI as well to be able to debug locally. We'll talk about evaluation in a bit. There's a lot to do there. And then hopefully easy deployment as well to be able to containerize and deploy your agents anywhere. So a bit of like, how does this actually look like? I think there's hopefully relatively easy kind of 3 things to keep in mind, but it's relatively easy to get going. First, a bit of instructions. So this can be fancy prompt engineering, or really just a few simple bullet points, or even a one-liner, depending on where you want to start, where you are in the life cycle. Then some tools. So any API, any docs or data, it's easy to wrap them up as tools. And then the third piece is obviously the model, some LLM. Obviously, we like, I'm partial to Gemini, but really the idea is here is work with a model that works best for you, offering that flexibility. And then the other part of this is, as you're designing and building your agent, actually being able to run it. And so this is about offering, that fully managed runtime. For us, this is our agent engine. And the idea is here is being able to leverage and kind of benefit from the investments that Google engineers have been making to kind of standardize agent runtime deployments across popular open source frameworks that are out there. And the idea, for a runtime like this is letting us do the DevOps for you. So leverage, a lot of the best practices for agent ops and observability. And I think the nice thing about this approach is I think the team has been really intentional about avoiding lock-in. So you can run these agents on Cloud Run, GKE. If you want to, you can DIY it, obviously. The intention here is to provide an easy path, though. So if you're looking for that, fully managed experience, this is it. All right, so we talked a bit about how Google thinks about building and deploying agents, and showed you some of the technology stack that Google itself uses to build its own AI applications. Let's talk a bit as well about the kind of multimodal, multi-agent world that's out there, and the frameworks that we see emerging to help facilitate this collaboration between agents, especially as agents are getting built by different groups, different vendors, different frameworks. How do we enable these agents to communicate and collaborate? And this is where the agent-to-agent or A2A protocol comes in. All right, so setting the stage here for potentially one of the next big shifts, as I highlighted earlier, in this kind of agent evolution, and this is that multi-agent world. And what this potentially looks like is agents are going to start coming from everywhere. So you'll have multiple frameworks running potentially in your own environment, alongside powerful agents coming from other vendors, other teams. And this creates, in some ways, kind of a fundamental challenge, is that these agents, especially when they operate as black boxes across different organizational or technical boundaries, they can't easily collaborate. So this means they can't easily share their tools, their memory, their plans, or even any of the intermediate reasoning steps that they're taking, their thinking, their thoughts, as it were. So these are all kind of like isolated agents. And the reality is that these interactions between these agents are often really dynamic and unstructured, and even multimodal, to just represent agents as specific tools. And so I think this is where this kind of gap and now opportunity emerges to move beyond some of the existing API specs and protocols, which we don't think are necessarily sufficient for the challenge. And so I think that's where we see A2A kind of emerging to do a bit more in this space. So given some of those challenges I highlighted, again, I think it seems clear to us that simply kind of tweak some of the existing standards doesn't work. And this is the space for agent-to-agent collaboration. And really, the fundamental driver here is making this an open protocol, and it's designed, purpose-built from the ground up, as it were, to handle those dynamic and long-running nature of how agents we think actually collaborate. So one, it solves the discovery problem by enabling an agent to publish an agent card. So this is a relatively straightforward way for an agent to advertise its skills and capabilities to the network. And I think the team that's behind this, we've really been thinking about making it enterprise ready from day one. And I think that's kind of key as we start thinking about taking these agents into production, into the enterprise, making sure that they're supported securely and with governed kind of experiences to manage them. The second part of this is making this practical and easy to adopt. So not trying to reinvent the wheel as much as possible. So you'll see here, it's using some of the quite popular, hopefully well understood standards out there, HTTP and others. And then, as you can see in the diagram, A2A as a protocol allows an agent to connect into a whole mesh of remote agents. The idea is leveraging their skills to respond and fulfill a user's request. So it's this communication that makes the multi-agent systems possible. So looking at a super quick example of what A2A looks like in action. In this quick example, Vicky's looking to resolve a dispute about an invoice. So the customer placed an order for a certain amount of product and only received a more limited amount. What does this actually look like manually versus in this agent world? So in the past, obviously Vicky would have done this all manually. So she's going to investigate across data sources. She's going to look up policies to figure out what the current policies are for this, initiate the refund process, and then communicate all of this to the customer. And I think you can start seeing what the opportunity looks like for agents to help automate some of this. And you'll see in the diagram here, this also requires connecting and working through a number of different subsystems to be able to fulfill an operation like this. So let's take a look at how A2A can help drive this. So I'll bring up a quick video here. And in this example, you'll see the ticket has come in with the customer requesting a potential refund given the discrepancy. Our initial agent is then able to work with the SAP Joule assistant in this use case, and identifying how many shirts were ordered versus how many were actually delivered. Now reaching out to another agent, in this case, Microsoft 365 agent, who's now processing what to do with this dispute and how to handle it. Then circling back to the SAP Joule assistant for more information. And now having identified, all right, there really was a discrepancy, having verified that this order discrepancy existed, and now making a recommendation on how to move forward. With the human in the loop here, that controller, Vicky, is now able to confirm that we should proceed with the refund, and it's now able to start creating the actual dispute resolution and refund processes to close this out. So you can see this is an example of a human working with an initial agent that's then able to collaborate with other agents out there and try and address this customer scenario. Here it is closing out with an email being sent to the customer. So I think that's a fun example of what this can potentially look like in production. I think one of the questions that emerges is, hey, this is not the only protocol. It's not the only framework that's emerging these days. There's a lot of others out there. In particular, MCP obviously seeing enormous traction out there, and it's an exciting moment. So I think it's worth talking about, all right, how does ATA and MCP potentially work together? I think these are kind of two foundational protocols emerging at the moment. And for me, the most important thing to communicate is that we don't see them as competitors, actually see them as complementary in a lot of ways. And this reflects two of the main challenges that we see emerging today. How do agents reliably use tools? And then how do agents collaborate? And so MCP handles part of that, about talking to tools and resources and information. And A2A handles another part of that, which is enabling agents to communicate. So first off, on the MCP side, it's really about standardizing how an agent connects to tools and APIs. So hopefully, instead of a mess of kind of custom integrations, an agent simply acts as an MCP client to connect to an MCP server. So this is a relatively clean, very reliable client-server model for using tools. On the other hand, we have A2A, so agent to agent, which is really designed for agent collaboration. So this is all around enabling agents to exchange rich information like images or data files, but critically being able to do this without having to share memory or tools directly. And so this helps keep the system secure. And as an open standard, it allows agents to be built on different technologies and still have them work together, hopefully seamlessly. Right. So how do MCP and A2A actually work together? And you can see a bit of the diagram there. In this example, you've got agent A, working through the A2A protocol with agent B. Let's imagine on some complex task. Each has access to its own tools, via MCP to help get the job done. And essentially in this example, A2A is handling the kind of what piece of collaboration. So what do these agents actually need to collaborate on? And MCP, in some ways, in this example, is handling the how part of this, of the tool execution, the retrieval. And I think it's this collaboration that ends up creating, a secure and scalable architecture for building these multi-agent systems. So some of the principles that you've probably already seen kind of emerging from this overview, as part of as part of this A2A protocol, enterprise readiness is absolutely a focus, and so making sure that enterprise grade requirements are built in from the ground up, keeping it simple and consistent. So hopefully making the protocol itself relatively brief and easy to understand, to lower the barrier to implementation. Keeping this async first, so we know that a lot of the agent interactions that are emerging are not simple, request response. And so this is, acknowledging that some of those tasks are going to be long running and probably involve waiting for, intermediate updates. Keeping this modality agnostic as another part of this. So, already highlighted this, the world is moving beyond text. So moving towards audio, video streaming, potentially even computer use style interactions. So try to future-proof this. And then finally, opaque execution. So this is enabling agents to be able to collaborate without needing to expose a lot of the internal workings. All right, so we talked a bit about building agents, deploying agents, enabling agents to communicate in multi-agent frameworks. The other part of this is, all right, how do we actually connect them to the data they need to be effective? And we started talking about MCP, obviously. I'll dive a bit more into this as well. I think part of the philosophy here is that in some ways, your data makes your agents. And as you can see, in this example, it's kind of an exciting moment blending both the power of agent reasoning alongside all the data and resources that are available to these agents. And part of this starts with being able to identify what's the right data for a query and how do you validate it and generate a response. And again, if you've heard, the agentic RAG, that's where I think a lot of the promise is. So being able to deeply understand user queries, be able to break them apart, especially when there's multiple nested questions, reason about the types of information that are needed to address them, figure out whether that's the relevant information that was retrieved, and then decide ultimately if what we got back is sufficient to return an answer to the user, or whether we need to run this loop again and begin the search. And there's kind of three buckets of data that we frequently see, developers and enterprise customers wanting to work with. Obviously, their private enterprise data is a huge one, but that real-time world information is also critical. And then I'll just highlight a lot of enterprises have made existing investments in integrating with trusted third-party data sets. And so how do you think about grounding your agents across these? But let's start with the first one, which is just that private enterprise data. Obviously, if a user or an agent is trying to discover information specific to a company's policies, a model out of the box won't be able to address it. But hopefully a grounded response is able to retrieve the right information and deliver an answer based on that company's specific corpus and policies. Now RAG is obviously the common method for doing this, and fundamentally it's about indexing an enterprise data to make it searchable. There's a retrieval step, collecting that information relevant to the user's query, and then finally that generation step where the model is able to leverage that context. Search is obviously a big part of RAG. It's about connecting a user's query with the most relevant information. The good thing about being at Google is it's a place where we're fairly familiar with search, so it's fun to be able to leverage a lot of those investments and research into the fundamentals of search for this new paradigm. When we actually start getting into building RAG systems, I think one of the things you can see is there's a lot of parts within it, from how you connect to your data, how you make unstructured content discoverable, how you refine the incoming user queries to maximize the search, the actual search itself, and optimizing results, and then finally kind of packaging this together to generate an answer. Within Vertex, within Google Cloud, we see kind of a suite of components helping developers do this. So indexing tools like a layout parser for doc processing, embeddings as well. On the retrieval side, a vector search and a re-ranker, and I'll talk about those. And then a generation side using Gemini or any model that you prefer. I'll briefly just highlight how we think about the individual components in this flow. So for us, this is our Doc AI layout parser. And the vision here is really making this kind of a one-stop shop to prepare any document for RAG. And this really addresses one of the core requirements in these agentic flows, is getting your documents and your data into a format that's searchable. And so think about converting raw documents like PDFs that have unstructured data, charts like you see on the right, making these easily searchable and discoverable. And part of this as well is the multimodal part of this. So combining visual layout information like where charts or elements are on the page, and their relationship as well with the actual textual information that's combined with it. So there's a lot of power in being able to convert not just obviously the text, but the images as well that make up a company's corpus and make those searchable. The other part of this is embedding. So once you've got your corpus organized and chunked, how do we actually generate embeddings off of it? For us, that's our Vertex embeddings models. Again, you'll see one of the key things here is kind of multimodality and then performance. So obviously performance in terms of the quality, the accuracy of the embeddings being generated, but also multimodal nature of this. So again, moving beyond text now to images and video. This is opening up new use cases, new kinds of retrieval workflows as well. Quickly on the vector search side, so obviously for customers working with vector search to retrieve the latest embeddings, this is a space where we've been leading for a long time in terms of the high performance nature of the vector search we offer, high scalability, and really continuing to build this out to make this easier for developers, particularly those who want to leverage search across their metadata and their embeddings, being able to do this in one place, being able to leverage the data wherever it's originally stored. So in this case, for developers that may have data in BigQuery, for example, being able to leverage the data that's already stored there and get the best of both worlds with vector search as well, and continuing to make this more cost efficient and affordable across use cases, across scales. And then the final piece I'll highlight here, kind of beyond a lot of what vector search actually delivers, is how this actually works in a two-stage retrieval process. And this is worth highlighting. I think I think there are many developers and customers that are familiar with this, but some aren't. And so this is worth highlighting when you start thinking about improving the quality of your agent systems and retrieval. At Google, it's been our process for a long time to manage this retrieval in a two-stage process. And so for us, this is in a first stage, using a combination of dense and sparse embeddings and vector search for that hybrid retrieval. So potentially generating a few hundreds of candidate results. The second piece here is the actual ranking step. And so here you're looking to score candidates and narrow it down to really only the most relevant results to pass to the LLM. And again, I think this is helpful to bring up because as you start thinking about what additional optimization opportunities are out there to kind of continue improving the quality of my system, adding a ranker to it can hopefully see very measurable, very tangible improvements to quality. And again, with the relatively low latency we see at this point, with relatively low trade-offs. So this is our ranking API. Delivers really great performance, as I said before, even for latency critical use cases, pretty modest levels of latency. And you can continue adapting these to your specific use case. I think about fine tuning as need be across this flow. So we talked a bit about kind of grounding on your enterprise information. The other quick thing I'll highlight is for your use cases where you need to connect an agent to real-time kind of world information out there. Think of things like web search. This is really an important fundamental capability, especially if you've got users and use cases asking about current events. And as I'm sure you know, if a user asks an agent about a current event without being grounded in real-time web information, you're just not going to get a helpful answer. Whereas if you've got access to that web search and the question comes in around current events, concerts in my area, hopefully you'll be able to deliver a much more accurate, relevant answer to the user. In Google Cloud, for us, this means grounding on Google Search as kind of the core capability. So the nice thing about this, it's really leveraging the power of Google Search and making that available to your agentic kind of workflows, and ultimately delivering factual, grounded, and hopefully useful answers as well. You'll see a bit of the design here as well. And the nice thing about this is Gemini can also dynamically choose when to use Google Search and when to rely on training data. And so you're starting to see more of those agentic capabilities baked directly into the model. And that's actually a good segue into thinking about, again, as more of these agentic patterns become available directly within Gemini, you'll start seeing things like query fanout, for example. And so this is the model being able to break down a user's query and identify potentially additional queries, additional related queries to run before returning the answer to the user. So again, a lot of these agentic patterns are now being in some ways pushed upstream to the models themselves. Another example of this is combining this with sequential searches. So the model, after planning on what series of questions to actually go ask, Gemini can then use thinking steps to reflect on the information it's retrieved and only then deliver an answer. So again, it's really interesting to see, again, these kind of agent patterns being kind of distributed both at the model side and potentially downstream as well in your actual applications. Another recent addition to this is grounding with Google Maps. And so for those use cases out there that are looking at local kind of fresh information, you can leverage the power of Google Maps for this. So if users are asking about local gyms in their area, your AI-powered applications can now deliver hopefully the most helpful, relevant results. All right, so we talked a bit about grounding there. The final piece that I want to highlight today is observability. And this is a really interesting space to think about. I think historically, we would have spent, I kind of think of the percentages have shifted in terms of how much time you and your development teams around you are spending on actually developing the application versus the eval part of it. And in this modern kind of Gen AI era, I see a lot more of the effort going into the eval side. In some ways, because it's relatively fast and easy to get started, but the eval side is actually a lot more challenging. Cool. So, as a quick example of what this actually looks like, the reality of developing in this Gen AI era is it's a mix of highs and lows. So you can rapidly prompt and code and assemble an initial prototype. It can work great. There's like high fives and celebrations to go around. But as you fast forward a few days or weeks and you start opening it up, the mood can change quickly, and you're flooded with feedback. And it may not be the kind of feedback that you'd expected. Suddenly, your initial testers or users are asking the agent to do things you probably hadn't even considered. And in some ways, this just reflects like the real world. It's, as you know, a lot messier than any kind of clean testing environment or potentially your early scenarios, testing scenarios. So you have to start refining your agent. And how do you think about prioritizing what to refine and what to build? And this kind of reflects like the fundamental issue here, is that these agents are in some ways very different from the traditional code a lot of us are used to. So traditional code is deterministic. You can tell a computer exactly what to do, step by step. But the reality is there's this level of randomness, of creativity in some ways, that are built into these Gen AI agents. They're stochastic. So these are probabilistic models, and they're designed to be creative, to handle ambiguity. And that's a lot of power. That's a lot of the power of them. But the trade-off here is potentially unpredictability. And even fixing one issue, the interesting thing is you can inadvertently create another issue. So metrics are no surprise, going to be a huge part of how we start understanding and evaluating our agents. And with a metrics dashboard that you build out, you can start comparing some of the performance across versions of your agent, so between an old agent and a new one. And for this, it's all about tracking, your key performance indicators, your KPIs. So this could be things like what percentage of the time does your agent actually successfully complete its task, or what's the error rate? How long does it take to respond? So latency. On the cost side, what's the cost per interaction per day, or in total? And even what's the total revenue for each piece of this? The thing about metrics is they can tell you a lot about what's happening at a relatively high vantage point. But you also need to be able to dig down deeper to figure out where in the flow do you want to spend your time refining and optimizing the patterns you're seeing. And this is where traces come in. Traces enable you to start drilling down and debugging at a much higher level of fidelity. So now you're starting to get into that detailed view of your agent's execution step by step. And so you can see exactly which tools the agent used, the inputs and outputs into those tools, and even a bit of the reasoning process itself. And so I think for a lot of agent developers out there, this is really like the invaluable kind of debugging task. So whereas metrics are the things you see on the dashboard, everything else that you can work with, we think of as kind of a trace. Complementing this, though, I think the reality is even with the very best metrics that you manage to set up, with access to all the traces you could wish for, don't forget about the human element. And I think this is critical to bring up. So your users, your internal testers as well, ultimately they're going to in some ways be the best source of insights around how the agent is really performing and potentially how to do better. So you can think about simple feedback mechanisms. This could be the thumbs up, thumbs down style button. You can do short surveys. You can add a comment box. And we'll show you some of the ways we think about integrating this feedback into your development loop, and some of the systems that can automatically learn from feedback like this. But I think the first step is thinking about how do you capture this information? How do you value it? So we've talked about agents in production, but the reality is we need to simulate production and automate some of this testing for the agent to work across scenarios. And this is the world of evaluations, or evals, because the reality is evals are a key component of this, of trying to simulate a real world scenario and see if the agent behaves how we wanted it to behave. It can probably seem like a lot of work, and at times, as I mentioned earlier, you may end up spending more time in the eval phase than you do in the actual initial kind of agent design and development phase. But in general, the payoff is critical and enables you to move beyond vibe checking your agents over and over, which is an approach that is really difficult to scale. So this is where this idea of agent ops emerges when we try and put all of this together. And I think the intention here is trying to make this a structured approach. So to organize all of these moving pieces. And it ends up being some level of overlap between the people that are out there, the process you're following, and the technology that's available to go do this. So there's a lot of tools out there, and a lot of what your agent is doing. There's a lot of different aspects to actually evaluate an agent's performance. Starting with a couple of them, what do you actually want to evaluate? And I think there's kind of two things that frequently pop up here. There's the final response, and here you can think about having some kind of rubric around how well an agent actually accomplished a task. But the other part of this is what we're calling now the trajectory. In a lot of ways, it's kind of just a fancy term for the actual steps your agent took behind the scenes to accomplish that task. And in general, you're going to want to be able to look at both of these because they both tell you helpful things around how your agent's actually performing. So in terms of how you actually evaluate this, human evaluation that we mentioned before is obviously a cornerstone of how you're going to be assessing these agents. And oftentimes you consider it the gold standard as it were, especially when you're working with skilled evaluators who are able to look at kind of efficiency, alongside of measuring the agent's resource utilization and helping understand adaptability as well. So evaluating the agent's ability to kind of handle unexpected situations. The trade-off, and there's a very real trade-off here, is that this can take a lot of time. So human evals, the reality is, can be subjective to the specific person, time-consuming, and potentially expensive, especially if you're trying to do this at a relatively large scale. So another option, as you start thinking about evaluating, both those outputs and those trajectories, is bringing in an LLM to help judge. And this is a really great idea. Part of the benefit is it scales beautifully. So it gets your data from people looking at your data. And so this is really leveraging the power of another model to assess the performance of an AI agent. And so some of the key takeaways: scalability. So obviously LLMs can do this at scale that humans struggle with. Very efficient. So can do these much faster, more efficiently than kind of a manual human assessment. And then consistency is a big one, which is now you've got the same LLMs applying a standard set of evaluation criteria, hopefully more consistently than human evaluators are able to. And that should reduce some of the subjectivity you may see in human evals. Again, so the highlights: it's scalable, it's efficient, and it's consistent. So these are all great things. But what are the trade-offs? As you start moving into more complex scenarios, the evaluations themselves become harder. And so part of this is thinking about starting small and expanding, and enabling the LLM to start catching up on agent behavior and start understanding some of those intermediate steps for those complex workflows. So as you're kind of seeing across these different eval options, there are very real trade-offs across these. I'll highlight one more, which is automated metrics. So you can start thinking about some of the core metrics that you see there to look at and measure quantitative performance of an agent. And so you can think of things like task success rate, for example. So measuring the percentage of tasks that were actually successfully completed by the agent. Also, more traditional metrics like precision, recall. So here you're looking at evaluating the accuracy of the agent's responses, particularly relevant for information retrieval or even classification tasks, as it were. So some of the benefits, you'll be able to very clearly measure, success rates and precision to recall. So these are very objective. These are very scalable metrics. But of course, there's a trade-off. You start missing out on some of the understanding of the performance for tasks that are requiring more creativity or more complex reasoning. I think the other part that's interesting here is sometimes these metrics are a little susceptible to gaming, as it were. So you start optimizing for those specific metrics because they're in some ways so easy to measure, but those may not be reflective of true performance. And so this is an interesting, area where you start thinking about, hey, how do I blend across these different, approaches for evals, and they're all telling me slightly different things. And I think that's part of the benefit of using all these different evals, but also how do you actually manage across humans, LLMs, automated metrics. And so again, this is a place where the Vertex team is also investing. For us, it's the Gen AI eval service on Vertex. And the idea here is offering a relatively scalable set of primitives to run and manage these Gen AI evals, and deliver some of this out of the box for these agent evals. Again, fully understanding that there's a lot to do here, but as I said before, it's like you'll probably move pretty quickly, as I'm sure you're already doing in the initial design and development phase of your agents. I think you'll end up spending a lot more time on the eval side, and so hopefully these are a set of tools that can make your life easier, thinking about, hey, how do I set up the initial set of metrics and how do I monitor them over time? You'll eventually end up with a few different metrics, potentially a few new metrics, which hopefully quantify how well your agent is performing and delivering. We've got some metrics, ready to hand out to you, but the idea is, hey, you can also go define your own, and whatever's relevant to your use case. So quickly, wrapping up, we covered a lot. We talked about where we are with agents today and some of the applications across industries, how we're hopefully trying to make it easier to build and deploy agents, how we connect them to each other to enable easy, secure communication, how we connect them to the data they need to deliver accurate responses, and finally, how we think about actually managing the evals across this lifecycle. A bunch of references here. I think we're going to share these out afterwards, but yeah, docs to ADK, A2A, grounding, and the eval service as well. Awesome. So I know that was a whirlwind. I know there's a number of questions. I'll start trying to work my way through some of them. And if I don't have time to get through all of them, I'm happy to follow up offline as well. I'm just going to scroll around a bit. So Vertex AI handle concerns around security and data governance when deploying agents in regulated industries. I think it's a great question. So I think Daniel is asking a question around security and data governance when deploying AI agents in regulated industries. A quick thought on kind of the Vertex philosophy here. One is making sure that taking kind of the best of traditional software development kind of best practices and bringing those into the agentic age. And so you'll see things when I showed that kind of agent platform before, whether you are designing and developing an agent, whether you're deploying it in a runtime like Agent Engine itself, you're still getting the benefits of a relatively sophisticated, mature cloud approach to compliance and security as well. The other thing that I'll say just quickly about security and privacy is for agents is like, this is where I think thinking through the approach to how your agents have access to data, how they connect to data. And so thinking through what resources they have available to them, what rules and controls you put in place, what kind of checks you put in place, potentially human operators, depending on the sensitivity, on the complexity of the task. I think that's where a lot of the power, particularly for regulated industries, comes in. The other thing is obviously traceability is a big part for some regulated industries of thinking through why did this answer come out the way that it did. And I think the benefit of being able to trace the thinking steps and the tool calls and the resource calls that an agent performed at this level, as we went through in the eval stage, is you start getting some of that audit, as it were. And I think you start telling a clearer story around why your agents are performing the way they are, especially as you start doing this in production. I need to share that data with regulators. Awesome. So I know we're out of time. There's more questions, so I will go through these and follow up and add answers where I can, and we will share the links as well. With that, I think I will hand it back. A tremendous thank you to everyone.